Hi, it's 1T, and in this video I'm going to be introducing you to factoring. So let's get started. So first of all, if I were to say multiply 3 times 4, you would get 12, and so 12 is what we call the product. Now my question to you is, what do we call the 3 and the 4? Well, if you said factors, that would be correct. What if I said factor 12? Well, you would be looking for two numbers that multiply to 12. Of course, we just saw that 3 and 4 do, but you also have 2 and 6 and 1 and 12. So notice there's three ways to factor here. The other thing I want to point out here is something that's important when you're factoring, and that is to understand that multiplying and factoring are opposites. So what that means is as we factor problems, we can always check our answers by multiplying. So that's a good thing. Let's go ahead and move on to the next slide. So now if I asked you to factor the expression 8x plus 16, can you tell me two expressions that multiply together and give you 8x plus 16? Now this isn't obvious, but if you think about the distributive property, you can come up with some that work. So for example, how about 2 times the quantity 4x plus 8? If we were distributing here, we know that 2 times 4x is the 8x, and 2 times 8 is the 16. And so really we're just doing the distributive property in reverse. However, there's two more answers you could have gotten. How about 4 times the quantity 2x plus 4? Or 8 times the quantity x plus 2? Now the problem here is we have three answers, and we mathematicians are a little picky about these things. We'd really like there to just be one answer here, and it's quite easy to make that happen. So we ask the question a little differently. We say, factor out the GCF, which means greatest common factor. And so if you look at these two terms, 8x and 16, you ask yourself, what's the largest factor for these two terms? The other way to say it is, what's the largest number that you can divide into 8x and 16? And of course, that would be 8. And so the answer that we would choose here, if we're factoring out the GCF, is 8 times the quantity x plus 2. There's only one answer, and that is it. Now, if you look at the other two cases, notice here you have a common factor of 2 still, and here you have a common factor of 4 still. And so in fact, that's one thing to look for when you factor, is to make sure that your terms inside the parentheses have no common factors. All right, so let's go ahead, and I need to say one more thing and then we'll do some problems. So I used to teach factoring and students got pretty good at it, but I realized that some students really didn't know what they were doing. So I just want to make sure that's not the case for you. To factor just means to write as a product. Notice what we started with was two terms, 8x plus 16, two terms added together, and in our final answer, we have 8 times the quantity x plus 2. We now have a product. All right, so to factor means to write as a product. All right, so our directions are to factor out the GCF, and our first problem is 9x minus 12. So if you look at the 9 and the 12, certainly 3 is a common factor, and it is the largest. And then we're going to write a binomial since we have two terms here. And so 3 times our first term should be 9x, and so that would be 3x. And 3 times our second term should be the minus 12 here. And of course, 3 times negative 4 is negative 12, so we would write minus 4. Now again, you can look inside the parentheses and you can see we have no common factors. So we are confident we got the GCF. And also if we distribute, we should get back to where we started. 3 times 3x is 9x, and 3 times a minus 4 is negative 12, which is a minus 12. And so we do get back to where we started by multiplying. Let's go ahead and look at another one. So we have x cubed plus 2x. So notice, oops, I'm getting ahead of myself here. the first term, if you were looking for a numerical number there, it would just be a 1. It's understood to be 1. So what do 1 and 2 have in common as the greatest common factor? It would just be 1, but that doesn't help us at all to break it down at all. So the only thing we really have in common in terms of factors here is x. Notice the first term has 3 factors of x times x times x. That's what x cubed means. And our second term has 1 factor of x. So the 2 terms have 1 factor in common. And so GCF here is x. What you'll find if you have terms in each, I should say, if each of your terms has a factor of some variable such as x, you'll end up taking the smallest power of that variable. So here that would be x to the first. So our GCF is x, and we know we need 2 terms inside the parentheses since we started with 2 terms. So we ask ourselves, what times x is x cubed? And of course that is x squared. Now there's a property of exponents. Let me go ahead and write this out. It's x to the m times x to the n is equal to x to the m plus n power. So basically, to multiply 2 powers of x, you just add the exponents. And so in our example here, basically this is x to the first times x squared. If you add the 1 and the 2, you do get 3. And again, the other way to think of it, though, is x squared means x times another x, that's 3x's multiplied, or x cubed. And so we should have x times x squared. Now for our next term, x times something is 2x. Of course, that would be 2, so we would write plus 2. All right, let's move on to number 3. We got 3a squared plus 18a. Why don't you go ahead and try to do this one? Go ahead and pause the video and then check my solution. All right, so you should have gotten a GCF of 3a. Of course, for 3 and 18, 3 is the largest number. You can divide those both by. And for a squared and a, they both have at least 1 factor of a. So our GCF is 3a. We're going to have 2 terms inside our parentheses. And of course, 3a times something gives us 3a squared. That would be a. And 3a times something is 18a. Looks like we just need a 6 there. And so we have 3a times the quantity a plus 6. Let's move on to number 4. So things are getting a little bit more challenging. Let's see what you can do with this one. We have 4x to the 6th plus 8x to the 4th minus 12x squared. All right, before I go on, I need to erase what I have up above here because I might need this space. I think I'm going to be in this same area here. So your GCF is 4x squared. And because for 4, 8, and 12, the largest common factor would be 4. And the smallest power of x, you can see, is x squared. Now this time we have 3 terms, so you should have made room for 3 terms in your parentheses. So 4 times this first number should be 4x to the 6th. And that would be just x to the 4th. And 4x squared times something should equal 8x to the 4th. We're going to need a 2 and an x squared there. And then 4x squared times something is a minus 12x squared. We're just going to need a minus 3 there. And so that's what you should have got. Now, what if you did something like this? You have 2x squared times the quantity 2x to the 4th plus 4x squared minus 6. Can you see where your mistake is? If you look inside here, isn't 2 still a common factor there? And so that's what's wrong there. All right, I want to show you one more thing. Let me erase this. Now, sometimes students have a hard time getting the terms inside the parentheses. So if you're having any problems doing that, there is another way to get those numbers. But the way I've been doing it is the way I hope you can do it, and that's the way we normally would do it. But if you're having a hard time getting these numbers inside the parentheses, here's what you can do. We said our GCF on number 3 was 3a. You can actually divide each of your terms by 3a. Notice the 3's cancel and a squared over a. In this case, we actually subtract the exponents 2 minus 1. So it's just a to the first or just a. And so that's how we get the a there. The other way to think of it is if you have two a's multiplied in the numerator over one a in the denominator, one of the a's cancels and you're left with just one a. When we have 18a over 3a, of course 18 divided by 3 is 6. Of course our a's cancel, and so we're just going to get that 6 there. We can do the same thing on number 4. Our GCF was 4x squared. And so you can simplify each of those to get the 3 terms in the parentheses. So for some of you that might be helpful, but again, the way we did it at the beginning is the way that I'll be doing it. And hopefully that's where I'd like to see you get to if you're not there. All right, on number 5 and number 6, I'd like you to go ahead and try those and then watch the video. All right, so on number 5, be careful. The GCF does not include a because there's no a in that last term. The only factor that these 3 terms have in common is 3. And of course, 3 times, times something is a squared. We just need the a squared there, don't we? And 3 times something is a minus 9a. That would be minus 3a. And 3 times something is 6. That would be 2. And so there's your answer there. On number 6, now this is like the ultimate test of what we've been doing with factoring out the GCF. Let's see how you did. For 24 and 16, the largest number you can divide both of those by is 8. And if you look at x to the 6th and x to the 1st, the smaller of the 2 powers is x. The other way to think of it is you have x to the 6th, which is 6 x's multiplied. So there's 6 factors of x in this expression or in this term. And in this term, there's only 1 factor of x. So they both have at least one factor of x in common. And then the smallest of the 2 powers for y is y squared. So 8xy squared is what you should have gotten for your GCF. And so we're going to have 2 terms inside the parentheses since there's 2 terms in our starting expression. And so what times 8xy squared will give you 24x to the 6th, y to the 4th. Well, it's kind of easiest to just work with one of the parts at a time. So what times 8 is 24? That's 3. And what times x is x to the 6th? That would be x to the 5th. And what times y squared gives you y to the 4th? That would be y squared. So you should have gotten 3x to the 5th, y squared. And then you have to ask yourself, what times 8xy squared gives you the negative 16xy squared? Well, the only thing there we need is a minus 2, because negative 2 times 8xy squared, that will give us the minus 16xy squared. All right, so hopefully you got those right. I'm going to give you one more. This one's a little bit different. We got x times the quantity x plus 2 plus 3 times the quantity x plus 2. So go ahead and give that one a try and then watch the video. All right, so basically we have 2 terms here. Terms, like if you look at 3a squared, that's a product of 3 times 2a's. So terms are separated by a plus or minus sign. So you have 2 terms here separated by this minus sign. So now down at number 7, we have a product, 2 different products. We have this product and this product there. And the common factor is x plus 2. Notice for the first term, you have x plus 2 times x. And in the second term, you have x plus 2 times 3. So we're treating x plus 2 basically like a single number. And so let's go ahead and write x plus 2 as our common factor. And now since there's 2 terms, there's going to be 2 terms in our parentheses. And we want to know what times x plus 2 is going to give us this first term. Of course, we're missing the x. And then we're going to ask ourselves, what times x plus 2 is going to give us the second term? And of course, that's going to be 3. And so the answer here is x plus 2 times the quantity x plus 3. And I made a mess of things here. Let me just clean this up just a little bit. Hopefully I don't mess it up too bad. There we go. I just wanted to show you how easy it is to check things. You have x plus 2 times x. That should be this first term, and it is. And then x plus 2 times the 3, that should be the second term, and sure enough it is. And so that is our answer, and that does it for this video.